we are going to keep working with the calculations, the same style of calculations as we did yesterday with the railroad tracks. However, we are going to relate it to the mass and the volume of a substance and then the mole unit as well. So reviewing from yesterday, just to get a firmer grasp of these terms, what were the three possible representative particles? Just give me one, Faith. Oh, molecules. Was it Justin that said something over there? What did you? Atoms, good. And the last one, Cora? Formula units. If you're feeling so inclined, you can abbreviate them as FU. I'm fine with that. And then what were the three ways that we talked about how we measure a substance? Mass, Cora? Volume. And what was that, Danielle? And then number or quantity. Good. So today we're just going to do a few problems. This one practices converting moles to a mass. So yesterday we didn't really work with grams. Grams is the unit of mass. But today we are going to look at how that works. So just like yesterday, you start your train tracks with what you were given in the problem. So 0.560 moles of chromium in this case. And then on the bottom here, we need moles of chromium, so it will cancel. And then the unit that we need to end in is grams. So yesterday when we looked at the molar mass, or the atomic mass rather, that unit was in AMU, correct? But another way of saying AMU that is exactly the same is grams over moles. So that's what the situation we have right here. We have grams over moles. So all we need to do to solve these problems is look up the atomic mass of chromium on the periodic table, which is 52. And it's 52 grams over the 1 mole. Our units, the moles of chromium cancel out. We're left in grams, which is what we want because it's asking for the mass. And then you can just run the calculation of 0.560 times 52 divided by the 1, and we should get something along the lines of 29.12 grams of chromium. So yesterday's ratio really focused on using 6.02 times 10 to the 23rd representative units. So that could be atoms, molecules, or formula units equals 1 mole. Another ratio now that we can add to this is that it's 1 mole to equals the atomic mass of an element. So these are adding to your little toolbox to help you solve these problems. What was that? OH, good as hydroxide. Now you need to look at, is this an ionic compound or a molecular compound? Is there a metal or not? It's ionic. So if it's ionic, we need to make sure the charges balance out to 0. So when it tells you that it's copper 2, this 2 is indicating the charge on your metal, and that will always be a positive. So copper is at a positive 2, and the charge on hydroxide would be -1. So are we balanced out to 0? No. So how do we fix this? Okay, good. We need a parentheses around OH and a subscript 2. So we can balance out the -1 to become a -2 charge. Are we clear on how we came up with that? Yes, a little bit. Leroy, do you remember doing this stuff a couple weeks ago? Okay. Let me know if you've got questions about this. And then, so now that we have our formula, it is asking for us to determine the number of moles in this 2.81 grams of copper hydroxide. So we start with what we're given, 2.81 grams of CuOH2. And we need to put grams of copper hydroxide on the bottom so it cancels out. But how do we figure out what number goes here? We can't just look at the periodic table because copper hydroxide is not on the periodic table. Is there a way to figure out the mass of copper hydroxide? Yeah, we need to do what we did yesterday when we added all the masses. So we have to look up the mass for copper on the periodic table, multiply it by the number of atoms of copper. Is it 63.55? How many oxygen atoms are in copper hydroxide, or copper 2 hydroxide? 2. 16. Remember doing this from yesterday's assignment? Okay. And then same with oxygen, 1.008. Then you add them all together once you do the multiplication. It's like 89 degrees in here. The bottom one is the only one I can't do in my head.
6.0102.
Are you sure about that? 2.016. I believe that one a little more. Okay, and then we add all three of these numbers together. And what did you get, Studi?
97.566.
566. And remember, this was AMU yesterday, but what was another way to write AMU? That's grams over moles, and we needed a grams, so now we can put 97.566 in 1 mole, and it's asking for us to determine the number of moles. So we are in the correct unit here for moles, so now we can just do the math. 2.81 times 1 divided by 97.566. Cora? 0.029, and that would be moles of copper hydroxide, or copper 2 hydroxide. Just so you are aware, when you are doing your homework, and I have not looked at any 10.1 yet, so I don't even know if this is an issue yet, but if you just simply write 0.029, you will not be getting full points. I need the rest of the units. Okay? If you want full points, you have to have the number and the unit. Just like, was it chapter 4 when we did these conversions? You don't get all the points if you do not have the unit. This will take effect on 10.2, since you were not reminded about this yesterday. Cora?
So I know you wanted them in 2 places after the decimal. Would it count also get 0.02?
Yes. However, I do like this better. When there's a 0 placeholder in there, I like 2 real numbers. Does that make sense? Okay, good. Questions about this style of problems? So the moral of the story is if you're given a compound you have to find the molecular mass in order to solve the actual problem. So then, why don't you go ahead and try this one on your own? All right. Do you guys still need some time to work on this, or should we go over it? Justin, you look like you were still working. Do you need some more time?
I just finished it.
Okay. Glenville? Go over it. Okay. So, how many molecules are present in 20.0 gram sample of chlorine gas? So, it seems easy enough because chlorine is an element, so we should just be able to look it up on the periodic table. Is that what you guys did? And then, so what did you get the mass of chlorine?
35.453.
Oh, 35. 35.453. How many of you remember that chlorine can only exist as a diatomic? And chlorine is really this. Ooh, very good. So, is 35.453 the correct mass to use in this calculation? No, it is not. You actually need to multiply it by 2. So you should get 70.906 grams over moles for chlorine's mass. And then your setup should look like this. And is it asking us to stop at moles?
No.
Nope. We need to take it one step further and go into molecules of CO or Cl2. And what were your numbers for this third box? Okay, Hallie.
Would be 1 mole divided
1 mole.
6.02 times 10.
Yeah, 6.02 times 10 to the 23rd molecules. So when you multiply all of this out, you should get 1.689 times 10 to the 23rd molecules of Cl2. So here, I want you to just remember that there are some diatomic molecules that you will need to be aware of when it comes to these calculations. Another big one would be hydrogen. Hydrogen, when it's by itself, always comes as H2. Oxygen would be another very common one. Oxygen and chlorine. These three are not the only three that come as diatomics, but they are probably the main three that we will work with that have that little twist to them. Moving on then. So now we are going to look at the mole-volume relationship. So liquids and solids, the volume will vary depending on the density of the substance. A gas, the volume remains fairly constant. Avogadro, the same guy from yesterday, he hypothesized that equal volumes of all gases at the same temperature and pressure contain equal numbers of particles. He said that gases are affected by pressure and temperature. They're compressible, that means we can squeeze their molecules together, and heat will affect them. So all of calculations involving gases occur at these standards, the standard temperature and pressure. We abbreviate that as STP. Your standard temperature is 0 degrees Celsius. In Kelvin, what is that? 273.15 Kelvin. And some of your calculations will need to be at standard in Celsius, and some of them will need to be at standard in Kelvin. And then your standard pressure is 1 atmosphere. So that allows us to calculate your molar volume of a gas, and that's the volume of the gas at a given pressure and temperature. At STP, 1 mole of any gas occupies the volume of 22.14. This is another one of those ratios that you can add to your list that will help you solve problems. Is that at STP, this only holds true if you're at standard temperature and pressure. And the problems will tell you if you are at standard temperature and pressure. That 1 mole of any representative particle has a volume of 22.4 liters. This would be another one of those tools. So let's look at a couple problems. A certain reaction produces 86.5 liters of hydrogen gas at STP. How many moles of hydrogen were produced? So here again, we have your hydrogen gas from the last problem. What should we remember about hydrogen? It's diatomic, so H2. That means we're at 2 times 1.008 gives us 2.016. Is that what it was? Okay. So then start with what you're given, the 86.5 liters of hydrogen gas. So we need liters of hydrogen gas to cancel. The only possible ratio we have, we're at STP, so we can use it, is the 1 mole of hydrogen gas to how many liters? 22.4. Oh, that's really, should have been paying attention. Okay. So, and it's asking for us how many moles. So we are in moles. So we can do the math. 86.5 divided by 22.4. And you get 3.86-ish moles of H2. We didn't even need to do that part. Typically, we like these volume problems because there's only one thing you can use. You have to use that 22.4 number, okay? Density, formula for density is mass divided by volume. Typically, your densities units when we're dealing with gases are grams over liters. So what is the density of nitrogen gas at STP? So density equals mass over volume. So at STP, what is the volume of any gas? Very good, 22.4. Now we just need to figure out the mass of nitrogen gas. So nitrogen, is it just N or is it N2? N2. So 2 times 14.01. So it'll be 28 something, right? 0.02. So that's our mass. You plug it in right here, 28.02. And our density, this is grams over liters, so that works correctly. 1.25 grams over liters of nitrogen gas. You could throw this into a train track if you wanted to, or you can just use your formula. I don't care. Okay. Oops, did you need me to go back?
No.
Okay. You do? All right, so why don't you give this one a whirl on your own. What is the molar mass of a gas whose density is 0.761 grams over liters at STP? What did you guys get, first of all? Let's just see what some of the answers are floating out there. Studi?
17.0464.
Oops, sorry. 17 point what?
0464.
0464. 17.05, which is like this, it's just rounded, right? Okay. Leroy, do these look close-ish? Yes, no?
Yes.
Okay. So let's just go through this problem quick. It kind of sounding like you guys are understanding this maybe. So density you're given is 0.76. The unit for density, 61, is grams over liters. And it wants the molar mass, so mass. And do we know the volume? Yep, what's the volume? 22.4 liters. So you can use your formula, density equals mass over volume. 0.761 equals mass over 22.4. And you should get a mass of, I have it rounded at 17.05 grams over moles. Why is this referred to as the molar mass? Not just mass? Yeah, because it's relating it to moles there. Good. All right. Did anybody get an answer for this last one? Yeah, Maddie?
It's probably way off, but I got 3.540.
Okay, 3.540. You're right that it is way off, 3.450. All right, so what is the volume of 79.3 grams at STP? So to do this one, we're actually going to have to do some railroad tracks. We're given the 79.3 grams of neon. So we need to cancel out grams of neon. And what's the only way we know how to do this? The only ratio that deals with grams that would make sense to use here. Can we go grams to liters? No, we don't have a ratio for grams to liters. What is our ratio to get into liters? Because that's our end unit, right? For volume. So what do we know converts into liters? Moles. So we need to, in this step, go from grams into moles. Can we go grams to moles? Is there a ratio that allows us to do that? Yes. So we can go moles of neon. And then this ratio says we can go from moles of neon into liters of neon. Now all we have to do is plug in the numbers. So for this second box here, what is our ratio based off of? Where do we get the grams? Where do we get this information from? Yeah, it's the atomic mass. Good. So we look for the atomic mass of neon. And it is 20 point something. 20.18 to how many moles? 1. Then what is our moles to liter ratio? 1 mole to 22.4 liters. Then we can do the math. The 79.3 times 22.4 all over 20.18. I think your answer should lie somewhere around 88 liters of neon.